Happy Friday. Valentine's Day weekend and President's Day weekend. An exciting weekend. I feel like it would be a good skiing weekend. Nice snow out there, snow tubing, something outside. I guess it's a little chilly though. So today we are going to look at the part 2, like question 2A, 2B on the writing equations worksheet, just kind of going through writing an equation for secant and cosecant. So we'll look at those two. I'm going to actually first start off with just a little bit of information about course selection for next year. So I'll talk about that first. And then today is kind of just reviewing graphing trig functions, writing equations for trig functions. So there's a review worksheet, and there will definitely be time in class for you to ask questions and to work through graphing and writing equations of the trig functions. So there is a quiz on Tuesday. I know quiz after a 3-day weekend sometimes isn't the best thing, but it's kind of the way it fell this time. If you do have questions on the review worksheet, please email me on Monday. I can create a Zoom with you if you have a lot of questions. Tuesday morning, there will be a Zoom open if you have questions that you want to go over as well. But send me an email. Don't hesitate to do that. It is just a quiz, so it isn't super long. Like there might be time in class to like go over general questions prior to the quiz on Tuesday, because it's just like one page front back, so 2 slides in Notability kind of thing. So before we talk about the homework, I just want to go over a little bit with you about course selections for next year and the options that you have, the opportunities that you have to take for next year. There it is. So I know there's a lot to read up on the screen. There's like a rule of thumb that you're not supposed to put a lot on a slide, but I was just pulling from the course scheduling book. So we have that big, thick, and it's not thick anymore, but it's, I don't know, it has like 70 different slides that you can scroll through. But all of the courses are in that big course selection book, which is no longer a book because it's just a file now that you guys can look at online. February 22nd is a Monday, like a week from Monday, when you can start scheduling for classes. And because you're in Trig and Pre-Calc, honors Trig and Pre-Calc, the next step for you would be to either take our CHS Business Calculus class or our AP Calculus class. That would be like if you're continuing on the same path, what you would take after this class. So a lot of students ask, what is the difference between the two? I mean, obviously AP is the advanced placement class. That is the like Calc 1 class. If you were taking it in college, that would be the class you would take. So if you take that class and you pass, you get credit for taking Calc 1 in college. The business calc class is our other option that Mr. Clark teaches. It is still a full year class. It is still a calculus class. But at Pitt, if you were a non-math or science major, but you still needed a math class to take. So if you were a business major, even an English major, maybe, what is the same, economics major, like that's the class that you would take. So you can't take business calc at Pitt if you are in the math science fields. Business calc is not quite as rigorous. Students coming from regular trig and pre-calc can also take that class. It doesn't contain the trig portion that AP Calc contains. So that's the biggest difference. AP Calc has trig, You have to know all of the trig functions. You have to know the unit circle. You have to know identities, which we'll talk about in the next chapter. You have to know trig in order to take AP Calc, which is why you have to take honors trig and pre-calc in order to take AP Calc, because we cover way more trig in honors than they do in regular. They cover a minimal amount of trig in regular trig and pre-calc. The business calc class is not like, you're not doing business things. So it's called business calc because it's like a class for non-math science majors to take. Yes, there are applications in there that are business related, but the calc is still calc. Like calculus is still calculus. It's a type of math, just like algebra is a type of math. Trigonometry is a type of math. So you're still going to be doing the same concepts in the two classes. You cover more in AP Calculus than you would in business calculus. Go more in depth. So if you have in this class in honors trig and pre-calc a B or higher, 83% or higher, we recommend you taking AP Calculus, especially if your path is to do something with math or science. If you don't have a math or science path and you don't have a B or higher, then we recommend you taking the business calc class. You still get PIT credit, and that PIT credit then transfers to other schools as well. There is a fee for the PIT class, but there's also a fee now for taking AP class, that test, as not the class, but the test as well. So both of them have a fee contained in it if you want to receive the credit. Are there questions like with the difference between the two, why you would want to take one versus the other? So like I tried to answer questions that I've gotten over the past. I was just talking to Mr. Clark to make sure I always kind of give the right information. So I have students who don't want to take a math class that is a calculus class. And we do have, of course, other options. We have probability and statistics, which is a half year or semester class. Does anybody have that this year? You have, did you have it or you have it right now? Pretty, what do you think? Like it was pretty difficult? Yeah. Did it get more difficult? Like the first couple weeks were okay, and then the second? Yeah, yes. But it's totally different math, right? Yeah. So it at least gives you a feel of a different type of math that you could take. If you remember in Honors Algebra 2 last year, we did some probability and statistics at the end of the year. It would have been during the COVID time. But it's a lot of formulas and testing and that kind of, yeah, it's a totally different type of math. We also have AP statistics. A lot of my students, if they don't take AP Calc, they end up taking AP Stat. They still want a full year math class. So if they don't take AP Calc or Business Calc, they end up taking AP Stat. So that would be a full year class that you could take as well. We have computer science. Does anybody have computer science right now? Anybody at home have computer science right now? No. Computer science is another class that you could take. We also offer CHS computer science, which again, you would be getting college credit for that class. So in math, we don't have, like, I feel like we're the department with the least number of elective classes. I don't know why. There's just not, I guess, a lot of math electives to take. Technically, this class is considered an elective class because pretty much you need to have Algebra 2 to go to college. That's kind of the requirement of a college, especially an athlete in college. But you need 3 credits. So if you're a sophomore, you still need to take a math class. If you're a junior, technically you have your 3 credits in. But we strongly suggest you taking a math class. So I have a Google form that I created. I created it. You don't have to do it now. It was Mr. Kane's idea, though. I hate when he has good ideas. Like, darn it, why did I think of that? But I made my own. I didn't steal his. So we did make a Google form just to get an idea of what you are thinking. And with having students at home and having students in school and having students that haven't come to school at all, we kind of thought it was the easiest way to get information from students and then for us to get information to you. So if you can complete that Google form at some point today, and you'll have time in class that you can complete it. It really is just like click, click, and then I just have a general question on there as well. And that will give me information about what my students are thinking about taking for next year, and then I can try and give you feedback as well. But our goal is to kind of give you a recommendation as to what we know of you as a student and what we think you would do well in next year. Any questions with course selection? Anybody at home have questions? So I wanted to go into or look at your homework and look at those two graphs for number 2, worksheet 2, number 2, 2A and B. Here they are. So I will say that when you're looking at these two functions, like I strongly suggest you playing connect the dots and draw sine and cosine in the middle. The equations that I have down below, you can have different equations. This is just one option. So you might have a different phase shift. It depends on what part of the graph that you're looking at. So your equations might not match identical. There are a couple of different options that you could have when writing the equation. If we look at 2A, use the graph to find secant and cosecant. So the first thing that I would suggest is find the middle. Like find D and A before you do anything else. So Kaden, the middle of this graph would be at 0, which is nice. Starts right in the middle. So right here's my middle. And then Kaden, the stretch from the middle to the top of the graph is 3. Yeah, so those are pretty straightforward. And then in between, I like to create a sine or cosine graph. To me, visually, it's easier to look at trying to find an equation using sine or cosine. So the max or the min creates a point for cosine. Where the asymptote crosses that middle horizontal line is also the intercept for sine or cosine. So this is a cosine graph. So a cosine graph makes a secant graph. So there would be my cosine curve. We need to figure out the period. The period, since I'm now looking at cosine starts at high and it ends at the high point. So when you're trying to figure out the period is from max to max. So pretty much this is one period of the graph. So if I go from negative pi over 2 to positive pi over 2, Jenny, our period is, yeah. Oh. So if I go from negative pi over 2 all the way to positive pi over 2. Yeah, there you go, pi. So to find B, remember the period is equal to 2 pi over B. Secant and cosecant, sine and cosine are both 2 pi. All 4 of them actually are 2 pi. Cotangent and tangent is the only one that's just pi. So that means our B value is 2. So these 3 pieces of information will be the same for sine and cosine, the same for secant and cosecant. So I could write a sine equation, a cosine equation, a secant equation, a cosecant equation, and those 3 pieces of information will be the same. They're not going to change. The phase shift is the part that changes. And the phase shift, it would be C over B. So we're going to think of one for cosine, which is really the secant. And then we're going to think of one for the sine, which is really the cosecant. So if you look at cosine, you're really finding the secant's phase shift. If you look for sine, you're really finding the cosecant's phase shift. Cosine starts at the max. Cosine starts high, moves low, and ends high. So that means that this first max point on the left, that is your phase shift. So the phase shift for cosine or secant starts at the first max point. So it starts up high and it moves down low. So that's at negative pi over 2. Which is our C over B value. Let me write it above. So you have to find the max, and then that is the phase shift. So whatever the max is for cosine is the phase shift for cosine, the phase shift for the secant. The sine starts in the middle. There are 2 points on here, they're at the middle. I have one on the left and one on the right. The sine function goes up high and then it goes down low. So when you're looking for the phase shift of sine, you need to find the middle point. And after that middle point, where does it go up? Because that's what a sine function does. A sine increases first and then it decreases. It has a hill and then it has a valley. So if I find that point at pi over 4, it's going up after pi over 4 and eventually it would come down and then it will go back up. That's where your phase shift is going to be located. So find the intercept or the middle that it increases after that point, and that is at pi over 4. So cosine has a phase shift at the max. The sine has a phase shift at the middle, but the middle must be increasing. It's called a positive sine graph. A positive sine graph increases, it goes up first. So then when you go to write your equation, we have an A value of 3. We're writing secant. The B value is 2. I have an A value of 3, writing cosecant, the B value is 2. Those are the same. The phase shift changes. Pi over 2 for secant, or pi over 2 for cosine, and it's a plus because it's a minus negative. There was no D value. And then for cosecant or sine, it's a minus pi over 4 because it's always x minus C over B. So find the middle for sine and cosecant, but that middle point must increase afterwards for a positive sine or a positive cosecant. Question?
For the cosine one, I did pi over 2 instead of negative pi over 2. Would that?
That's fine. Yep. So you could, yep, because it will start. So you could definitely start it at positive pi over 2 because it does continue beyond them. So sure, you could say it shifted from 0 to that location. Evan?
For the secant, was negative 3 secant of 2x also work?
Yes. So if you said negative, then you have to make sure you have that negative. Yeah. So if you said a negative 3 times the secant with no phase shift, but if you don't have the negative, then it's wrong. Why would you have a negative there? Yeah, it flips the points. So he's looking, saying there's no phase shift right here, but it's starting down at the minimum. So if it starts at the minimum, it's a negative graph, but there isn't a phase shift that you would have to worry about then. So you could write that as well. So you can see there's not one correct answer. There's a couple of different options you have to choose from. Questions? So if you look at B, again, find the middle of the graph. Hannah, where's the middle of B? And then what's A? 2, yeah. So here is the middle, and the A value is 2. So find the middle first. And then you can draw in the graph where the middle crosses the asymptote. And it goes up and it goes down. Ooh, that's sloppy. A little better. So this would be my sine graph. It looks exactly like sine. The period is the entire distance from negative pi over 4 to 5 pi over 4. Hannah, what did you say for the period?
3 pi over 2.
Say it again.
3 pi over 2.
Sorry, I apologize for asking you to repeat yourself. So I have 5 pi over 4, adding another one makes 6 pi over 4 or 3 pi over 2. And then if I set that equal to 2 pi over b, and what'd you get for b? 4/3. It's kind of weird having that 4/3. But that's our b value. So D, A, and B are the same for both. And then we need to just find the phase shift. So we need our phase shift. This looks like a sine graph, so I'm going to think sine versus cosecant. And we need our phase shift for cosine or secant. So sine, it looks exactly like sine. That starting point at sine, negative pi over 4. Easy to see visually. It's that first point on the left. It's where it starts in the middle, where the x-intercept should be, and it goes positive or max after that. So negative pi over 4. Cosine's a little trickier. This point right here, that's where the cosine is. How do you figure out that point? Because that's where the cosine starts. And I know you can look at the answer and say, well, that's what the answer key says. But how would you figure out that point? That's one way that I could calculate what the cosine value is starting at. Jenny, do you have an idea?
Well, when I first looked at it, I thought it was pi over 4, but then I saw that there's a tick mark next to it.
That little tick mark next to it.
So it has to be positive in the tick mark.
Yeah.
I
So,
saw that it was 5 pi over 4, and so I figured that the pi over 2 is 2 pi over 4. So then that one would have been pi over 4, so half of that would have been pi over 8.
yeah, nice. So there was a little, and I know the tick marks are tiny, but the graph is counting by pi over 4. So there was a tick mark, and then you have a pi over 2, and then 3 pi over 4, 4 pi over 4, 5 pi over 4. So that is not a pi over 4 value where the max for cosine is located. But it is halfway in between, and that would be that pi over 8. So halfway in between 0 and pi over 4 is pi over 8. Nice explanation, Jenny. So this would be a pi over 8. And then you would write your two equations using the information. Questions? Any questions that I didn't answer?
Could you go over 1b for how to find the tangent equation?
Yeah. So, Darby, what did you get for D and A?
So I got 1 for D and 1 for A. For B, not A.
Oh, you wanted to do B, not A? Is that what you said?
Yeah.
I'm sorry, Darby.
No, that's
Thanks for-
fine.
Okay, so 1 is the middle, and 1 is A. And then the period would be the distance from pi over 4 to 3 pi over 4.
Which is pi over 2.
So when you go to find your B value, you just get
2.
2. Nice. Okay, so tangent starts in the middle. What's shown up here is really a cotangent graph because it's decreasing. So when we go to write our tangent graph has to be negative. So I'm going to have a negative tangent. A is 1, so it's a negative 1. B is 2. And then the D is 1. If you find the middle of the graph, that would be your location of the tangent's phase shift. So cotangent is wherever the asymptote is. The tangent is where the middle of the graph is, which is like the x-intercept where it's crossing the x-axis, or in this case, that sinusoidal axis. So that location in the middle is at pi over 2, and that would be your phase shift. So it's negative because this is a positive cotangent graph, therefore tangent has to be negative. And then the middle of the graph is what you're looking for tangent. So
Okay,
cotangent, you look at the asymptote, and then tangent, you look at the middle of the graph, the intercept.
the answer key has y equals negative tan 2x plus 1. So I think that's where I was
Yeah,
confused.
so I could extend this graph and like I could make another graph. And I could then place an x-intercept. And then it wouldn't have a phase shift. So that would be
Oh,
showing
okay.
that, like, you can always extend the graph and keep it going. But if I wanted to write an equation for what the graph has, I could write x minus pi over 2. So there are like multiple answers. Your answer isn't necessarily wrong. So maybe I
Okay.
should write another equation on there. Any other questions? Nice question to ask, Darby. Okay, so I just want to show you what the homework is for today. It is posted to Google Classroom. It is also this is the next page in the packet, but it should be on Google Classroom. But just to kind of explain it so you understand what you're looking at, I'm going to make sure this is posted for you. Do you see the worksheet posted? You just saw a notification pop up, so it literally just posted. Yeah, it literally just posted. So section 4.6 review worksheet. And then at the top of this week is where I have, oh, I didn't post it yet. I will get the Google form posted for you like momentarily, but it'll be at the top of this week, the Google form, which is just like a questionnaire about what you want to take course-wise. So if you want to open up the review worksheet, there is a chart. You're not graphing any of these functions. You're just filling in the chart. And notice that there's sine functions, cosine functions, tangent, secant, cosecant, cotangent. All the functions are listed here. When you're looking at the amplitude, which two functions have an amplitude? Grant? Do any other functions have amplitudes? No. So when you look at this chart here, number 1 says sine, so the amplitude is 2. The second one is cosine. And then going down, there's another one that says cosine. Actually, that amplitude should be positive. Amplitude is a positive value. A is -4, but the amplitude is still the distance. The rest do not have an amplitude, so you would say none. Because they stretch to infinity or negative infinity. They don't have an amplitude. So yes, there's an A value. We know that A value changes the graph, but it's not the amplitude. So don't get fooled by that question. When you're asked what the amplitude is for secant, cosecant, tangent, cotangent, there is no amplitude. Remember the period for tangent is pi over b. The period for cotangent is pi over b. The other 4 are 2 pi over b. So that's another thing to remember, the difference between those two. The phase shift is still c over b for all of them. So there's a little chart. The next group of questions, there are 4 of them. Want you to write a equation for the graph shown. And you could kind of take this in a couple of different ways. So like letter A, if you look at 2A, what does that look like? What's the graph look like in letter A? Which function does it look like? Cosine. Yeah, it looks like cosine. So I would write a cosine equation because it looks like cosine. Letter B is probably secant or cosecant because it has those parabola things. So draw in the other graph so that you can see that other function. Letter C looks like tangent or cotangent, and then letter D looks like sine. So you're just writing one equation for those. And then there are a couple of more that you're writing equations with, and then there are 4 questions to kind of graph, just to review the graphing. So I'm going to stop talking. You have about 10 minutes that you can work on this worksheet. I'm going to get that survey posted because I don't have it posted. Shame on me. Anyone at home have questions?